Okay, so when it comes to exponential functions, so the first one that we should consider is e to the x. Now the derivative of e to the x is e to the x. So the integral of e to the x with respect to x is also e to the x, just plus a possible constant. Okay. Okay, so now let's consider what would be the integral of, let's say, e to the 3x with respect to x. Now, when we take the derivative of e to the 3x, what does it do? It spits out a 3, okay? So, because of the chain rule, meaning that we multiply by the derivative of what's on the interior, derivatives are associated with multiplication. But integrals are antiderivatives. So to compensate for the chain rule, integrals are associated with division. So this would be e to the 3x divided by 3 plus a constant. So even on like sine of 2x, something like that, that would be negative cosine of 2x divided by 2 to compensate for the chain rule spitting out that 2, okay? All right, so I mean, it doesn't matter what's on the interior. Let's say we had the integral of e to the 7x with respect to x. Yeah, that's e to the 7x divided by 7 plus a constant. Okay? So we're always trying to compensate for the chain rule. But not always just the chain rule. Okay? Let's say we did the integral of 7 to the x with respect to x. Okay? Now, when we differentiate 7 to the x, it becomes 7 to the x multiplied by the natural log of 7. Okay? Well, to compensate for being multiplied by the natural log of 7, what we're going to do is we're going to divide by the natural log of 7. That's 7 to the x divided by the natural log of 7 plus a constant. And so, if we had the integral of, doesn't matter, 2 to the x with respect to x. This would be 2 to the x divided by the natural log of 2 plus a constant. Okay? And that's the basic rules that we're going to go over in class today. I'm going to cover linearity next, but some of y'all should be wondering, well, if you did a 7 to the x divided by the natural log of 2, why didn't I ever cover any integral involving logarithms? That's going to be saved for calculus 2. Okay? The integral of the natural log of x, or any logarithm, ends up incorporating integration by parts, and that's a technique that you'll end up learning in calculus 2. It's a very important technique. It is applied in so many different ways. I remember applying it in my dissertation. So y'all get to see that later on. Okay? Now, a very important property of integrals is linearity. Okay, so what do I mean by linearity? The integral of f of x plus or minus g of x with respect to x is equal to the integral of f of x with respect to x plus or minus the integral of g of x with respect to x. So if integrals are being added or subtracted, you can do each integral individually. Okay? So let's say we have the integral, let's say x to the 5th plus, I don't know, x cubed plus 7x plus 12 with respect to x. Okay, so all of these guys are going to incorporate the power rules, so we're just going to integrate each one individually. And so this becomes x to the 6th divided by 6 plus x to the 4th divided by 4. And we don't care about the 7. Multiplying by a constant, it doesn't matter. You're integrating with respect to x, so you have to pay attention to the x. So that's plus 7, now x squared divided by 2. And the integral of a constant is a linear function, so that just becomes 12x, and then plus c. Okay. Let's do another one. Let's say we integrated sine of 5x now plus cosecant squared of x and minus 12 to the x with respect to x. Okay. All right, so okay, remember when we integrate sine of x, it becomes negative cosine of x. So this would equal now negative cosine of 5x divided by 5. Okay. Now the integral of cosecant squared of x. What's that? That is negative now cotangent of x. Dealing with a lot of negatives at this point. Well, what is that one over there? Well, I have 12 to the x. Think about it as, well, you're just going to divide by the natural log of 12 to compensate for the fact that if you took its derivative, it spit out a natural log of 12. So that's 12 to the x, minus 12 to the x divided by the natural log of 12, and then plus c.